Alright, 3.6, comparing exponential functions with linear and polynomial functions. Okay, objective. Students will be able to differentiate between linear functions, polynomial functions, and exponential functions. Alright, so I have three scenarios here. So suppose you got a new job, and your employer offered to pay you three different ways. For each way, he would calculate your pay at the end of the month and pay you for the 30 days worked. Okay, so you're going to get paid for 30 days either way. You get to choose which option you want to get paid. The first option is you just get paid a flat rate of $200 a day. The second option, option B, is get paid $10 a day, but then you multiplied, that $10 a day is multiplied by the number of days worked. So you already get paid $10 a day, but you're going to multiply that by the total number of days worked. So if you work 30 days, you get 30 times 10 times another 30. Okay? A little bit weird. The last one is get paid 1 cent, but your pay would double every day that you worked after the first day. So if you worked one day, you get 1 cent. The next day, 2 cents. The next day, 4 cents, and so on. Okay? So which way would you pay? It says, example 1, come up with an equation that represents each situation where x is the number of days worked and y is the amount earned depending on the number of days you worked. Okay, so we're going to come up with a function for each of these. The first one is probably the easiest one. Situation A, you're just getting $200 a day. So I could say A of X, or I said to call it Y. Doesn't really matter. We'll call A of X, we'll call that $200 times X, because it's just a flat rate. 200 for every day that you work, you get $200. So 2 days work, 2 times 200 is 400. Or 5 days work, 5 times 200 is 1,000. So that's how you could figure out how much you get paid for situation A. Okay, so there's an equation that we came up with for situation A. Let's talk about situation B. We'll call that B of X. And for B of X, they said it's $10 times every day and then times every day again. Well, we're actually going to call, we called dx. So I'm going to say this is like saying 10x times x, and x times x we know is 10x squared. So b of x equals 10x squared. Okay, so we got a little bit different type of function there, a different way of being paid. And then lastly we have situation C, which we will call C of x. Okay, now for situation C, this one's a little bit different than how we've written equations, even in this chapter, but it's kind of like some of the exponential equations we've used, in that our initial value is going to be 0.01. But when I say initial, I actually mean on day 1. Typically when I say initial value, that means times 0, so when x is 0. But now I'm going to say when x is 1, I want it to equal 0.01. So I'm going to start off with a 0.01. And I'm gonna double that every day that I work. And so I'm going to raise that to the power of x for the days that I work. But remember, if I plugged a 1 in here for the first day, I want to be able to get back 0.01 over here. Meaning I want 1 cent for the first day of work, and 2 cents for the second day, and 4 cents because I want it to double every day. Well, the problem with how my equation is written right now, if I plug in a 1, 2 to the 1 is 2, and 2 times 0.01 is 0.02. So on the way this equation is written right now, I'm actually going to get 2 cents on the first day, which is wrong, right? I only want 1 penny on the first day. That's what the thing says. Get paid 1 penny, but your pay would double for every day that you would work after the first day. Well, since it's doubling after the first day, what I can do is just take away that first day by saying x minus 1. Now this will work perfectly. On the first day, I get 1 minus 1 is 0. 2 to the 0 power is 1. And 1 times 0.01 is 0.01. That's exactly what I want on the first day. On day 2, I would get 2 minus 1 is 1. 2 to the power of 1 is 2, and 2 times 0.01 is 0.02. So this is going to follow the pattern that I want. So remember, since I'm doubling it after the first day, I just take away the first day up here. That's all it is. So now I have these three situations, three formulas. And they're all in terms of x. I know I started putting D there for days, but let's just use X for days. And I want you guys to fill in this table. You're going to do this on your own. You're going to use a graphing calculator to do this. You have your three functions, A, B, and C. And just go ahead and just fill in all the values. Here's your x values, or your number of days. So this is what you're going to put in for the x on your graphing calculator. And you can use Desmos or another online graphic calculator if you don't have your own. And you're going to fill this in. And then you're going to plug in situation B, which is like 10x squared, and you're going to fill this in. And then you're going to put in situation C, which is 0.01 times 2 to the power of x minus 1, and you're going to fill this in. And what I want you guys to do is figure out which one should you really choose. Which method is actually going to pay you the most? I mean, obviously, situation A starts off at $200 after the first day. Situation B only starts off with $10. And situation C only starts off with a penny, right? So we could see already very clearly that situation A is going to be the best after day 1. So if we're only working for 1 day, we should definitely do situation A. But I want to know which way we should do if we're working for 30 days. So evaluate that, fill out this chart, and then after you fill out this chart, I have a summary question that I want you to answer. It says, how would you describe the different growth rates of each payment method? So how would you describe these 3 different rates? And which one would you choose and why? So which one are you going to choose and why? So have fun filling that out. Looking to see it all filled out on your own using a graphing calculator or an online graphing calculator like this one at Desmos. And answer this question for me. All right. See you guys on the next video.